Alright, good morning. I'm going to try and give you the material on my own rather than searching videos that try and fit what we're doing. So hopefully this helps a little bit better. So very quickly, recapping last week, we did see some rational exponents, so fractions in the exponents. What that meant was we can rewrite it in radical form. So a to the m over n is the root of the radical. M is the exponent that's inside with it. They just match up. So looking at an example, if we have 8 to the 2/3, that means it's really the cube root of 8 squared, which is the cube root of 64, which in turn is 4. Now, next example, 4 to the 5/2 means we take the square root of 4 to the 5th. Now, I'm not totally positive what 4 to the 5th is off the top of my head. So there is another way we can go about this that wasn't shown in the videos last week, but will be useful today. So let's try and do this from the first problem to prove my point. 8 to the 2/3. It's the cube root of 8 still, so cube root of 8, and then we're going to square that entire answer. So the cube root of 8 is 2, 2 squared is 4. Notice we get the same answer as we saw before, maybe dealing with some smaller numbers, potentially. Let's try it again with the example I had. 4 to the 5/2 is the square root of 4 to the 5th power. Square root of 4 is 2, easy. 2 to the 5th, if you still need a calculator for it, probably a little bit easier though, smaller numbers at least, so 2 to the 5th is 32. And that's a little bit easier with the values that we have to deal with at least. Now, big note portion here, I'm going to be focusing on this second portion. Alright, so that second portion is what we're going to focus on today. Okay? But either one works just fine. I'm going to focus on the second one. Now, a couple of examples using the new way. So 4 to the 1/2, we rewrite it, square root of 4 to the square root of 4, and then all to the first. I don't need to see the 2 written there or the 1 written there. That doesn't really mean much to me. I'm just writing it just for notes purposes. So usually we see it like that, so the square root of 4, which would be 2. Next one, 8 to the 2/3, would be cube root of 8. And then that whole answer is squared. So cube root of 8 is 2, 2 squared is 4. Move right down the line. Another example. 32 to the 3/5 is 5th root of 32, all to the 3rd power. 5th root of 32 is 2. Now this is a prime example of why I would do this. I don't want to cube 32. That'd be insane. You'd be dealing with a much bigger number than you want to deal with. So 5th root of 32 is 2, 2 cubed is 8. Now you still may need a calculator, and that's fine. But just giving you some examples or new ways to do things, that's all. Next, we're recalling all our exponent properties. I'm not going to talk through them. You guys can see it in the printout if you need to, but we're going to be using all these properties. So just make sure you're familiar with each of those. We looked at that beginning of the year-ish. Now, some other things we need to keep in mind is fraction rules. So we're using rational fractions, or rational exponents now, fractions in the exponents. Reminder here, again, I'm not going to really spend time doing this. You can see it. I left pretty good notes on this slide here, so you guys can read through it. Multiplying fractions, you just go across the top, across the bottom. 6 over 20, reduce it, 3/10 is your answer. Adding and subtracting, you need the same thing on the bottom. Alright, you just add the tops. At that point, once you have the same thing on the bottom, it's 11 over 10, reduce if you can. Can't in that one. So if you have questions over that kind of fraction stuff, let me know later on. Alright, the examples that we're dealing with here. I got 6 examples for us that'll help us out with our homework this week. 81 to the 1/4, all to the 4th power. deal with the exponent rules first. So exponent rules in this one tell us we can multiply the powers. So 1/4 times 4, and I write stuff out. I'm writing more steps than I need to. I am going to need to see some work, so not as much as I'm showing, but some work needs to be involved. So I multiply those. 1/4 times 4 is just 81 to the first. Showing, again, a lot of extra work, and 81 to the first is just 81. So we got that. Now, next one. 8x to the 15th, all to the 1/3 power. Again, just like the last problem, take that power, give it to everything inside. This is what it looks like when it's actually multiplied out. So it's 8 to the 1/3 times x to the 15th times 1/3. 8 to the 1/3 is the cube root of 8. 15 times 1/3 is x to the 5th. Cube root of 8, we can figure that out. That's 2. X to the 5th is already simplified. That's our final answer. Last one on this slide. Now, when there's no parentheses, I just straight up multiply what's being given to me. So I'm going to rearrange this first. So I'm given this. I'm going to rearrange this. So just for myself and for notes purposes. 3 and the 4 are going to be multiplied together. The x's are going to be multiplied together. 3 times 4, simple, just 12. Now the x's, you have to get the same thing on the bottom. If we go back to our exponent rules, we're in this top form here. I need to add the exponents. So we're adding and subtracting fractions, in this case adding. So I need to get them to have the same thing on the bottom. So 1/2 is also 3/6. 2/3 is also 4/6. Then I can add the exponents like it shows there. Next part's my answer, 12x to the 7/6, because I couldn't multiply it out. Or sorry, I couldn't simplify it. So we got those. 3 more examples. Same deal as the other ones. I just give that 1/2 to everything inside. So that's what you see there. Notice I snuck in a negative exponent. We'll deal with that here in a minute. This is everything being multiplied out. 9 to the 1/5, just giving 1/2 power to everything inside. So that's that. Square root of 9 is 9 to the 1/2. Multiply everything out. Square root of 9 we can figure out is 3. If you guys remember about negative exponents, it just tells us to move. If y to the negative first is negative up top, we move it to the bottom, it becomes positive to get our final answer of this. 5 here, just straight up simplifying the fraction. If you guys remember, I went ahead and always split this up. 125 divided by 5, we get 5. And then I'm dealing with the exponents, x to the 7th over x cubed. Notice I went ahead and changed the exponents already to make sure they have the same thing on the bottom of the fractions, because now I'm going to subtract. So I get 5 and I subtract. 7 minus 3 is 4. 9/15 minus 4/15 is 4/15. Final answer, done on that one. Last one, a little bit of everything here without some simplifying fractions. I just go ahead and give that power to everything inside. So I got that. It's going everywhere, top and bottom, everywhere. That's it, just truly written out there. All right. I mistyped the problem, so let me get that going real quick. There should be 3 halves. The work is right now. There we go. All right, everything's good. So I just rewrite everything, deal with the radical. So 9 to the 3 halves is square root of 9, then cube. 4 to the 3 halves is square root of 4, then cube. So square root of 9 is 3, 3 cubed is 27. Square root of 4 is 2, 2 cubed is 8. Then I just multiply the exponents there. Nothing too crazy with multiplication. I get my final answer of this. X, Y, and Z are separate, so I can't simplify any of those. So that's what we have there. That's it for my examples. you guys will be seeing a worksheet and a printout of these notes. So if you guys have questions, let me know. Alright, I hope this worked out a little bit better. Stop and pause this as you need. But that's it. Alright, bye.